Now we know how to balance an equation. Let's talk about predicting the formulas of the products for some different types of reaction. Here we have a synthesis or combination reaction. We've got two things combining to form one thing. And we have a metal and a non-metal combining, so we're going to make an ionic compound as a product because it's a metal and a non-metal. Now, a very common error that students make when they see this type of problem is they say, okay, Rb plus O2 must make RbO2. And that is not correct. You do not just carry subscripts from the left-hand side to the right-hand side. Instead, you have to balance the charges if you're writing the formula of an ionic compound, just as we learned to do when we learned to write chemical formulas. So what I suggest you do is in the margin of the page, go ahead and write the charges on each of the ions. So rubidium is in group 1A, so it will form 1+. Oxygen is in group 6A, so it will form 2-. So we can see from our charges here that we're going to need 2 rubidiums to balance 1 oxygen. So the formula of our product will be Rb2O. Okay, so you do not just carry subscripts from the left to the right. You never balance an equation with subscripts. You balance an equation with coefficients. And remember, coefficients are numbers that we write in front of the formulas. So we have 2 rubidiums on this side, so we need to put a 2 here. We've got 2 oxygens on this side, so we'd need to put a 2 here. This then gives us 4 rubidiums, so go ahead and change that to a 4. So now we have 4 rubidiums, 2 oxygens, 4 rubidiums, 2 oxygens, so it's balanced. Okay, here's another combination or synthesis reaction. We've got aluminum combining with oxygen to form aluminum oxide, an ionic compound. So we need to balance the charges. Aluminum is 3+, oxygen is 2-. The easiest way to balance a 3 and a 2 is to cross them over. So we get Al2O3 as our final product. Okay, so again, we did not carry the subscripts from the left to the right. We balanced the equation using coefficients. Now, when you've got a 3 and a 2, the easiest way to balance those is just to swap them, cross them over again. So let's put a 3 there and a 2 there. When we do that, effectively what we're doing is we're finding the lowest common multiple of 3 and 2, right, which is 6. So now we've got 6 oxygens on this side and 6 oxygens on this side. That gives us 2 times 2, 4 aluminums. So we'll put a 4 here. So we've got 4 aluminums and 6 oxygens. So it's balanced. Okay, this next equation is a double displacement, and a double displacement reaction involves swapping partners. So the cation from one goes with the anion from the other. Okay, again, we're going to form 2 ionic compounds, so we need to balance the charges to get the formulas. So we've got silver, which is 1+, nitrate is 1-, calcium is 2+, and chlorine is 1-. And go ahead and crisscross them over like this. We're going to swap partners and balance charges to get the formula. So silver goes with chlorine. We've got 1+ and 1-, so that's simply AgCl. Okay, and then calcium goes with nitrate. Calcium is 2+, nitrate is 1-. So we need 2 nitrates to balance 1 calcium. So it's going to be plus calcium, 2 nitrates, like this. Okay, we needed 2 nitrates to balance 1 calcium. So now we need to balance the equation. Our formulas are correct. Again, we did not carry the subscript 2 from the left to the right. We need to take care of that with a coefficient. Okay, that gives us 2 chlorines. It also gives us 2 silvers. So we put a 2 here. Now we have 2 silvers and 2 nitrates. And over here we have 2 nitrates. So the equation is balanced. Okay, the last type of reaction we have is an acid-base neutralization. Remember, you're going to recognize an acid because it has an H at the front. And for now, you're going to recognize a base as something that contains an OH-. So we have a little mantra. Do you remember it? Acid plus base gives salt plus water. And this, again, is a double displacement. So let's go ahead and write our ions in the margin. We've got H+, SO4 2 minus, Na plus, and OH minus. And our mantra says acid plus base makes salt plus water. The water is the H from the acid and the OH from the base. So HOH is H2O, water. Go ahead and write the water immediately so you don't make a mistake with that later. Okay? You know the formula of H2O, so just go ahead and write that down. And then sodium and sulfate. 1 sodium is 1 plus and 1 sulfate is 2 minus. So we're going to need 2 sodiums to balance 1 sulfate. So the formula of our salt will be Na2SO4. Remember, salt doesn't just refer to table salt. It's not just sodium chloride, okay? It's any ionic compound. So acid plus base gives salt plus water. We need to balance it. We have 2 sodiums here, so put a 2 there. That gives us 2 plus 2, 4 hydrogens, so put a 2 there, 2 oxygens, 2 oxygens, 1 sulfate, 1 sulfate. So we're done. So the takeaway from this particular lesson is do not carry subscripts from the left-hand side of the reaction to the right-hand side. You balance the equation with coefficients, not with subscripts.